Well, welcome to this tutorial which is going to look at CHOPS, or channel operators, in Houdini. There's an excellent introduction to channel operators on the Side Effects website, and I highly recommend that you have a look at it. We're going to try and cover some slightly different ground in this tutorial today. I'm going to start by examining some traditional animation on this sphere. I'm going to set keyframes so that the sphere moves to each corner of the box in succession. So let's do that by moving to a top view, which I'm going to do by pressing space 2. And to set a keyframe, we Alt left click on the parameters we want to keyframe. So in this case, I'll left click on Translate, and I'm going to move to frame 25, move the sphere to the next corner, and Alt left click again, and then move to frame 50, move to the next corner, Alt left click again, and finally move to frame 75, and then move to the final corner and Alt left click. So we should find that as we scrub through the channels, the sphere moves to each corner in turn. Let's press space and 1 to move back to the perspective view. Now what happens if I wanted another object to follow the movement of my sphere? Let's lay down a box. I'm going to raise it up just above, a little bit above the grid. Well, one way to do this, if we wanted our box to follow the sphere just in the X and Z directions, would be to take the X translate value of the sphere, copy the parameter, paste copied relative reference, and repeat the same for the Z parameter. And what we have now is at each frame the translate parameters in X and Z for our box are being fetched from the animation that we've got applied to our sphere. So as we move along the timeline, we can see the box follows the sphere. Well, what happens if we wanted the box to follow the motion of the sphere but not exactly? For example, we wanted to lag behind a bit and overshoot at the corners. This is quite a common thing that you want to achieve in animation, and it could be achieved by using expressions. So here we can see that we've got a channel expression which is grabbing the value from the translate X parameter of our sphere, and in fact there is a channel CHF function which allows you to grab a channel at a specific frame, and we could use that to create a lagging effect. It all gets rather complicated quite quickly. Fortunately, there's another way. The CHOPS allows you to take the animation of one object and apply it to another after it's been altered in some way. Let's see how that works. First of all, I'm going to take my box, I'm going to get rid of the animation or the expressions that we've applied there, and then I'm going to start by applying the effect we want to the sphere. So I can do that from Houdini 10 onwards by using the motion effects menu. Now all motion effects are several common uses of CHOPS, and they've been assembled into this menu which allows you to set them up much more easily than was possible in previous versions of Houdini. So I want to apply a lag. So let's select that, and we get this dialog box which allows us to set the parameters of the lag. And all I'm going to do is increase the overshoot parameter slightly, like so. And let's see what that's done. Well, first of all, we can see that our parameters for our sphere have turned this orange-brown color, and that is because they've been overridden, and if we click here we can see they're overridden. When you see something saying overridden, that means that there's an operator inside a CHOPS network which is overriding those particular channels, and we'll see that in a minute. First of all, let's see the nature of the effect. Let's slide around our box. Nothing seems to have happened, so let's go into a top view and have a look. And we can see it's not very clear that our sphere is overshooting very slightly the corners as it gets to them. And that's because we've applied a lag and overshoot. Let's examine how that's actually working. So if we dive inside our CHOPS network, we can see we've got two nodes. One of them is a channel node. The second is our lag node. The channel node is what's bringing in the information from our translate parameters on our sphere, and it's been set up automatically when we used the motion effect menu. And what we've got here is one set of channels overridden. We've got a name, and that name is the name by which the channels are going to be known in the CHOPS context. We've then got some parameters which determine the type of the channel. In this case it's three float values, and it's tx, ty and tz, and then we have here some values. And in fact what we've got here is our original animation. Those are the Bezier keyframe curves that we have animating our sphere. It's not really necessary to understand in detail what this is doing, but the name here tells CHOPS that we're collecting data from a sphere object, and that we're collecting it from a parameter whose name begins with t. And because we've got a 3-value float parameter, the node automatically adds x, y and z to the t, so we get tx, ty and tz as the three parameters that we're collecting from our sphere. In other words, the translate parameters of our sphere. Now, like most other networks, we can see some information about what's happening by middle clicking on our node. And we can see that we've got three channels. The start to end here is telling us over which frames the channels exist. In this case it's up to frame 75, 3.13 seconds. And then it tells us the range of each of the channels. So it's each of them are varying from -5 to 5. We can in fact still edit the animation on our original sphere, and we can do that in the channel editor. We can see that these values are available on animation curves, and we can change them like so. And I'm going to just undo that. So this is bringing in our values for tx, ty and tz, and we have channels called tx, ty and tz. And then we've got our lag operator. So what is the lag node doing? Well, it's adding lag and overshoot to our animation curves. Lag is about delaying the animation curve, and overshoot is about changing its shape when it changes direction. It's much easier to see this if we can visualize the CHOPS node here. And even though we've got this node selected, we can see that there's nothing appearing in the channel editor. And the reason for that is that, in fact, it's the motion view which allows you to visualize the effect of a CHOPS node. And note, unlike the channel editor, there are no editing handles here. You can't, in general, adjust these curves in the motion view. Now I've increased this overshoot a little bit for effect. Let's examine as if we have it down at a very low value, then almost nothing is happening. If we increase it, we can see that here, where the curve changes direction, we get this bump, and that represents the overshoot. It's easier to see if we can visualize both the original animation curves and the result of the lag node. And we can do that by shift-clicking on the display node of the first of our chops. And we get both sets of curves at once. If we go up to our graphs menu here and select two graphs, and then graph per chop, we can see them side by side. And as we can see, we have our TX animation curve here, which goes smoothly from -5 to 5, and then is flat, and then goes down again. And this is the result, this is the lag, and that we can see from the label here, it's lag 1. In that case, the TX curve goes up, and then there's a bump, and then it settles down, and then goes down again. So that's the effect of the overshoot part of the lag. And we can also see that the curve is offset slightly, and that's the result of the lag part of the lag. Why the two sets of values? Well, you can change the extent of the lag depending on whether or not your animation curve is on an upward slope or a downward slope. In most cases you'll want to have them the same. So this is a classic example of what CHOPS can do. It can bring in data that's varying over time and is represented by a curve, and it can manipulate the curve. How then do you get the results of that manipulation back into your object? Well, the answer lies in this toggle here, which is called the export flag. At the moment it's toggled on, and you can see it's the same color as the overridden parameters in our sphere. If I turn this off and then go back up to the sphere, we can see that the sphere's parameters are no longer overridden. So what's the effect of the export toggle? How does it know where to put the information that it's got? Well, part of the answer lies on this common tab here. And we've got an export prefix, which is /object, and we've got channels which are called sphere object 1 tx. The colon separates the name of the parameter from the name of the object from which the parameter was taken. So in this case, Houdini reconstructs the place to put the channel from taking the parameter name, the object name, and the prefix. So in this case we will have a destination for this channel of /object /sphere object 1 /tx, and as we can see, sphere object 1 translate parameter is tx, ty, and tz. So that's how it knows where to override. What happens if we wanted to override parameters other than the ones that we got our animation from? As indeed we want to do here, because we've got a box that we want to animate with the lag, while the sphere maintains its original animation. Well, I can take away the export flag, and I can lay down an explicit export node. And I'm going to set the display on this, and I'm also going to set the export flag on this. Which channels do I want to export? Well, in fact, I want to keep the Y position of my box the same, so I only want to export TX and TZ. And my path is TX, and my node is the box object. And now if we go up to the box object, we can see that the TX value is overridden. If I go down again into the export and put in TY here, we'll find that tx and ty are overridden. In fact, of course, I've made a mistake. I wanted to override tz, so I can go back in here and change that to tz. And now we should see that two parameters of our box are overridden. Let's see what that looks like. As we scrub through, we can see that the box lags behind the sphere. Let's see what happens when we reach a corner. You can see that the box overshoots. It's overshooting over the edge of the corner. Does the same there, and finally there. And we can go in here and increase these parameters on the lag. And show that a bit more dramatically. And now we can see a really big overshoot as it gets to the corner. So I set up this example to demonstrate how a CHOPS network works in general. In fact, there's an easier way to achieve this particular effect. Just delete this. And that's to use the lag tool on the shelf here under the animation tab. So if I select that, and then it asks me to select the object to lag, in other words the box, I hit enter, and then select the object to follow, in other words the sphere, and hit enter. And it brings up our familiar lag parameters, and I can increase our overshoot, shut that down, and we should find that we get the same effect that we had earlier.